In this video, we're going to go over Chapter 9, Section 3, testing a claim about a population proportion. So I'm going to do one example situation and then go through each of the steps and each of the concepts that were discussed in the videos. The only thing that I'm not going over is when you're given the computer output, because that was fairly straightforward. There are quiz questions that give you a computer output. So you can always ask questions if you don't understand those later. So the situation that we're going to look at is an emergency fund is defined as a savings account that has a balance equal to at least 2 months living expenses. An article in a financial magazine claims that 70% of American adults do not have an emergency fund. To investigate this claim, a financial advisor selects a random sample of 150 American adults and finds that 95 do not have an emergency fund. The financial advisor would like to know if the data provide convincing evidence that a true proportion of Americans who do not have an emergency fund is less than 70%. So let's just pull the numbers out of the problem and identify them. So their claim is 70%. So that means that P naught is going to be 0.7. And then he selects a random sample of 150 American adults. So that's the value for N. So N is 150. His results help us with P hat. So P hat is going to be his result. So 95 of these do not. So we're doing 95 divided by 150. And that's going to give us P naught, or sorry, P hat, which is about 0.63. So his results were 63%. Our claim for the null hypothesis is 70%. So the first example is essentially the first step, which is identifying the null hypothesis. So the null hypothesis, remember, is always an equation. So it's that the true proportion is 70%. So P equals P naught. Remember that what we want to add here is what the description of P is. So P is the true proportion of Americans who do not have an emergency fund. And I'm just going to copy and paste that rather than write it. So P is the true proportion of Americans who do not have an emergency fund. I'm going to highlight where I got that from. Okay, so that is our population proportion. Remember that an alternative hypothesis has to do with what they're claiming. So they're claiming that this is less than 70%. So we're going to be claiming that the true proportion is actually less than 0.7. Okay. So remember that null hypothesis is always equal. The alternative hypothesis is given in the problem. So then, are the conditions for inference met for conducting a z-test for one proportion? So remember that we're looking for the word random when we're describing our sample. So random, that one's good. We need 10%. So if I think about it, they've given me a sample size of 95. And if I'm talking about all American adults, 95 is likely to be less than 10% of all American adults. I'm just going to write US adults. Okay, so even though they didn't give me a population size, 95 is a very small number in terms of how many adults are in the United States. So large counts, I have to check N times P naught for this. So N is 150, P naught is 0.7. And so that gives me a value of 105. So that one's good. And then I have to also check 150 times 1 minus that 0.7, 1 minus P naught, and that gives me 45. So both of these are greater than or equal to 10. So that condition is met. So we've met all three conditions to conduct a z-test for one proportion. So what is the value of the test statistic and the p-value for this test? So for this, we're going to plug in p hat, p naught, and n into the z equation. And then we're going to have to use the z table, which they will link to in the question, to find the value for the p-value. So remember that our p hat was 0.63. So we're doing 0.63 minus p naught. P naught was our 0.7. Divided by the square root of 0.7 times 1 minus 0.7 divided by our sample size n was 115. Okay, so if we calculate the numerator, 0.63 minus 0.07 is, minus 0.7 is negative 0.07. That denominator, that big piece underneath the radical, is approximately 0.0374. And this gives us a z value of approximately negative 1.87. So if I'm looking at my answer choices, because it's multiple choice, I can eliminate probably 2 answers based on that number. Okay, so from here, what I'm doing is I need to think about what kind of significance test I'm doing. So remember that ours here was the lower tailed test. So with the lower tailed test, we are just using the probability value from the table. Remember, if it's an upper tailed test, we're gonna have to do 1 minus the value from RZ, or we change the sign and look at the value on the Z table. If we have a two-tailed test or two-sided test, we look up one of them and then we double it, because it means that if I had a not equal to, it means I want to find the probability that it's in either of the two tails. It doesn't matter which one. So I'm not saying that it's supposed to be bigger. I'm not saying it's supposed to be smaller. I'm just saying that it's different. Okay, so we're going to do the most simple version, because if we look back at our problem, remember it's less than 70%. So we're finding the probability that Z is less than negative 1.87. And again, this less than came from this less than or this less than based on our problem. Okay, so if I'm looking at the Z table, that means that I want negative 1.8 and then 7 is 0.0307. So on the Z table, I have 0.0307. If for some reason this was greater than, remember that I would have to do 1 minus that number to find my probability, to find my p-value. Okay, so if that was greater than, I would do 1 minus that number, or I would look up positive 1.87. Okay, so you have 2 options there. And then again, if it was two-sided, I would always look up the negative and then double that number. Okay. So the p-value is 0.0307. So those are the 2 answers for this second part of the example. Third part, I apologize. So then for 4, it's asking us what conclusion should the financial advisor make using an alpha level of 0.05 significance. So 5% significance test. I'm going to just copy down my p-value. So the p-value is 0.0307. That number is less than alpha. Remember that if that number is less than alpha, we are going to reject our null hypothesis. Okay, so that means that the true proportion being 0.7 is false. Okay, so if that was greater than 0.05, we would fail to reject the null hypothesis, right? We aren't saying that we're accepting our alternative hypothesis that the true proportion is smaller. We're just rejecting that it is exactly 70%. Okay, so that's the full significance test for one problem. The next thing that it talks about is power, and power is the probability that a test will find convincing evidence for the alternative hypothesis when a specific alternative value of the parameter is true. So the way that we can increase the power of a test, this is what we want to do. So increase the power of a test. There are three different ways. The first way is by increasing the sample size. The second way is by increasing the significance level. And the third way is to attempt to detect an alternative parameter that's further from the hypothesized parameter. So in terms of sample sizes, if my larger sample size is going to give me more information about the population, so it's going to increase the power of my test. It's going to make my test more reliable. The significance level is the probability of making a type 1 error. So if we increase the significance level alpha, then we're less likely to reject falsely, meaning we're more likely to reject correctly. And then finally, if the parameter is further from the hypothesized parameter, it's because it's easier for us to detect and reject big lies rather than small lies. Okay, so remember that the further it is from the hypothesized parameter, the better. Okay, so in example 5, what value of the alternative hypothesis would provide the greatest power for this test? Remember that our null hypothesis included the p-naught value of 0.7. So we're looking for which one is the farthest from 0.7, and that would be 0.4. So 0.4 would be the correct answer here because that would increase our power. Remember, in general, there's questions that just ask you what will increase the power of the test: increasing the sample size, increasing the significance level. Increasing the sample size, increasing significance level, and then detect an alternative parameter farther from hypothesized. 1 and 2 are usually going to be the answer and something that's verbal, and then they test your understanding of the third one numerically, like we did in example 5. So that's everything from 9.3, again, except for reading computer output. And so if you need help with that, you can go, I would go back to the video. I think he does a good job. Otherwise, you can always schedule a meeting and ask for help then.